And welcome to this next video in which we will talk about basic pixel relationships. So this is the book that we are referring to. Let me just enable my pen here. Okay. So here we have our pixel P at coordinates f of x comma y. Okay, at coordinates x comma y. Here x is the row and y is the column. So the row just above pixel P would be referred to as x minus 1. Row just below pixel P would be referred to as x plus 1. Now, y is the column for pixel P. So the column just before pixel P would be y minus 1 and just after pixel P would be y plus 1. So all the pixels which are surrounding this current pixel P are the neighbors of pixel P. And how do we refer them to as? So if the pixel is just above pixel P, in the row above it, it would be row number x minus y, but the column will not change because it is in the column of pixel P. Similarly, here, pixel here in this location where my pointer is is at the location f of x minus 1, but it is in the column y plus 1 because it is just after column y. So it would be referred to as f of x minus 1 comma y plus 1 and so on. So all these are called as neighbors of pixel P. So if the pixels are located at the positions shown, which is highlighted in peach color, these are called as four neighbors of pixel P. And how will we refer to them? Refer to them as this pixel will be f of x minus 1 comma y. This pixel here would be f of, any guesses? Okay, f of x comma y plus 1. This will be f of x plus 1 comma y, and this one will be f of x comma y minus 1. So these are called as four neighbors. These are the neighbors in four directions of pixel P. Similarly, we have got diagonal neighbors also, and I'll just quickly tell you how to refer to this particular pixel. It would be f of x plus 1 because it is just below the pixel P next row, and y plus 1. So these are the diagonal neighbors. And the four neighbors plus the diagonal neighbors will give you 8 neighbors of pixel P. Now, based on this fundamental of 4 neighbors, 8 neighbors, diagonal neighbors, we have something called as adjacency or connect. So whether we can connect the two neighboring pixels or not will depend upon the rules which are defined here. So first in for adjacency, okay, we say that if two pixels have the values from a particular set V, and if Q belongs to four neighbors of P, then they can be connected. So we have an example here. We have defined our set V as 1. So for two pixels P and Q to be connected, they both should belong to this set V. That is, they should have a value of 1 because our set V just has one value, which is 1, and Q should belong to four neighbors of P. Then for 4 connect, P will be equal to Q will be equal to 1, that is both will have the same value, and Q will be in the 4 neighbors. So here we have this example. Here Q can belong to any of these locations which are highlighted. So for example, if Q is here at this location and value of P is 1, value of Q also has to be 1 for them to be connected. Or let me say, if the value of Q is 1, or if the value of Q belongs to V, value of P also belongs to V, set V, and Q is in one of the locations of four neighbors of P, then they can be connected or they are adjacent. Similarly, we have 8 adjacency. So again, pixels P and Q should be from set V. So they should have values from set V only, and Q should be one of the 8 neighbors of P. So if Q is at the location here, in any of the locations which is highlighted, for example, if we take our Q here, P and Q can be connected or are called 8 adjacent if P and Q both have values from set V. Now in our set V, in the current example, it just has one value which is 1. So P, if P is equal to 1 and if Q is also equal to 1 and Q is one of the 8 neighbors of P, then they are called as 8 adjacent or 8 connect. Similarly, we have M adjacency, mixed adjacency. Now here the rule is that the two pixels P and Q should have values from V, and we have two conditions here. So here we assume that P and Q have values from V. Now there are two conditions. If the location of Q is in N4P or NDP and N4P intersection N4Q does not belong to V, then they are M connect. Let us understand this with the help of an example. Okay, so here what we are trying to tell is that Q can be either 4 neighbors of P or it can be D neighbors, diagonal neighbors of P, and values of P and Q both should be equal, should be from set V. Only then we can go ahead with this adjacency. Let us take this example to get a proper understanding of what is M connect. Let us say if Q is in one of the 4 neighbors, that is if Q is maybe here or here or here or here, right? Then P and Q would be connected by M adjacency if both the values of P and Q belong to V. That is first condition. Okay. Now, what is the second condition? Just erase whatever is annotated here so we don't get confused. Okay. Now, the second condition is, for example, if Q is in diagonal neighbors of P, is a diagonal neighbor of P, and value of P and Q both belong to V. But can we still straight away connect them? No, we can't connect them because there is a condition here that 4 neighbors of P intersection 4 neighbors of Q, this value should not belong to V. What do we mean by that? So what are the 4 neighbors of P? These are the 4 neighbors of P. What are the 4 neighbors of Q? 4 neighbors of Q is this, this, and this. And which 4 neighbors of P and Q intersect? This 4 neighbor of P and Q intersect, and this 4 neighbor of P and Q are intersecting. So if values at the intersection of 4 neighbors of P and 4 neighbors of Q belong to V, then we cannot connect P and Q. That means if the value here at this location and at this location is, or not and, or, so if value at this location or at this location belongs to V, then P and Q could not be connected. Okay, so let us see this with the help of an example. Uh, we can easily do 4 connect here in this image. So here let me say my set V is 1 comma 2. So for 4 connect, what is the condition? 4 connect, the condition is that if P, this is my current pixel P, and if this is Q, I can connect this P and Q if Q is 4 neighbors of P and they both belong to set V. So here I can connect these two, right? Similarly, these two could be connected for 4 connect. What can we do here in 8 connect? These two could be connected because they both belong to set V and they are 4 neighbors. These two could also be connected because they are 4 neighbors. And can we connect these two? Yes, we can connect these two because they are 8 neighbors and both the values belong to V. These two could also be connected for the same reason. Now let us see for the M connect. For M connect, can I connect these two? Yes, I can, because 1 is 4 neighbors of 2. Can I connect these two? Yes, we can connect, because this one is 4 neighbor of this one. This one we can connect. Can we connect this 2 to this one? Okay, let me just erase all the ink again. Okay, so the question is, can this 2 and this diagonal one could be connected? So let me say that this is my pixel P and this is my pixel Q. So now for M connect, we have to see whether P and Q belong to V. Yes, both of them belong to V and they are diagonal neighbors. If they are diagonal neighbors, we have to see the pixels at the intersection of their neighbors. So which are the neighbors of pixel P? Neighbor of pixel P is this one here and this 0 here, this 0 here and this 0 here. Which are the neighbors of pixel Q? Neighbors of pixel Q is this one here, this 0 here, there could be a pixel here and there could be a pixel here. And which is the pixel at the intersection? This one is the pixel at the intersection and this 0 is the pixel at the intersection. Now we have to see whether pixel at the intersection belongs to V. Let us come to this pixel at the intersection. 0 does not belong to V. However, this 1 belongs to V. Because pixel at the intersection belongs to set V, we cannot connect. P and Q could not be connected. For them to be connected, pixels at the intersection should not belong to set V. Okay, so here is the example where we show why M adjacency is used. So sometimes when you are using 8 adjacency, there is a ambiguity whether we should take this part here or we should take this part. To remove this ambiguity, M adjacency is used. Because when we use M adjacency, this one here, suppose this is my P and this is Q, this could not be connected at all. And why it could not be connected? Because here my set V is equal to 1. And the pixel at the intersection of neighbors of P and Q, one of them belongs to V. This intersection pixel belongs to V. So this connection could not be there. So there is no ambiguity on how to reach a particular pixel. So that is why M adjacency is used. I would end here and we will meet in the next unit of image enhancement. Thank you very much.